Good morning, students. Yesterday we discussed the topic effect of further immersion, and today we will discuss some examples based on it. So our first example is a rectangle is immersed vertically in water with two sides horizontal and at depths h and a plus h respectively below the free surface. We are to prove that the distance of center of pressure from the upper side is A into 3h plus 2a upon 3 into 2h plus a. You can see this is the rectangular area which is immersed vertically in water with two sides horizontal. Depth of this side below the free surface, this is given to be h, and the distance of this side from the free surface, that is given to be a plus h. We are to find the distance of center of pressure of this rectangular area from the upper side. This is the upper side. It means we are to find this distance. Now let us take the distance of center of pressure of this rectangle is x from the free surface. This is x and this distance is h. It means we are to find the value of x minus h. To find this, we will use the formula which we discussed yesterday. To use that formula, first of all, we require the depth of center of gravity and center of pressure of this rectangular area before further immersion. Means in the position when one of the side of this rectangular area is in the free surface. So let us take the position of this rectangular area with the side AB in the free surface, and let us take rho is the density of the water. Suppose the length of this side BC is A. So the depth of center of gravity of the rectangle, that will be at the distance a by 2 below the free surface, and depth of center of pressure we already obtained in the previous exercises, that if a rectangle has one side in the free surface, then the center of pressure lies at a distance 2 by 3a below the free surface. So we have obtained the depth of center of gravity and the depth of center of pressure in this position. Now let us assume that this rectangular area is further immersed to a depth h, and x be the depth of center of pressure in the new position. So using the formula which we discussed yesterday, we get the value of x which is given by h square plus 2 into the depth of center of gravity before immersion, which is a by 2, into h plus a by 2 into the depth of center of pressure before further immersion, that is 2a by 3. In the denominator we have a by 2 plus h. Simplifying this term, we get the value of x which is given by 2 into 3h square plus 3ah plus a square upon 3 into a plus 2h. Now, because we are to find the distance of center of pressure from the upper side, which is this distance, and this is x minus h, and we have already obtained the value of x, so we can put the value of x here. So x minus h after simplification will be a into 3h plus 2a upon 3 into a plus 2h. So this gives us the required distance. Next example we have discussed already yesterday, to find the center of pressure of a triangular area immersed in a homogeneous liquid, the depth of whose angular points below the free surface are alpha, beta and gamma. The result of this example should be remembered as a formula, and we will use it in the next example. So the center of pressure of the triangular area, which you will have to remember, is alpha square plus beta square plus gamma square plus alpha beta plus beta gamma plus gamma alpha upon 2 times alpha plus beta plus gamma. Here alpha, beta and gamma are the depths of angular points of the triangle. Now our next example is find the center of pressure of a square lamina immersed in a fluid with one vertex in the free surface and the diagonal vertical. This is a square lamina ABCD. Vertex A is in the free surface and diagonal AC vertical. We have to prove that center of pressure divides vertical diagonal in the ratio 7:5. Now because this square is symmetrical about this diagonal, so center of pressure will lie on this diagonal. So let us take P is the position of center of pressure. Then we have to prove that the ratio of AP and PC, that is 7:5. Now to prove this, because this square is a compound body consisting of two triangular areas, area ABC and area ACD. So we will use the formula for the center of pressure of compound body. And to use that formula, we require the depth of center pressures of these two triangular areas below the free surface and the thrust on these two triangles. So let us find them one by one and substitute in the formula. So first of all, let us find the depths of center of pressures of these two triangular areas below the free surface. And these depths we have assumed x1 and x2. x1 is the depth of center of pressure of triangular area ABC and x2 is the depth of center of pressure of triangular area ACT. And thrusts we have denoted by P1 is a thrust on this triangular area ABC and P2 as a thrust on the triangular area ADC. Now let us find x1. So by using the formula which we discussed in the previous example, the center of pressure of the triangular area, the depth of whose vertices are alpha, beta, gamma, is given by alpha square plus beta square plus gamma square plus beta gamma plus gamma alpha plus alpha beta upon 2 times alpha plus beta plus gamma. Now for this triangle ABC, alpha is the distance of depth of vertex A, which is 0, depth of vertex B, that is beta, which is this distance, which is half of diagonal AC. Now the side of the square is having the length A, so the diagonal will be A root 2 and its half is given by A by root 2. So this distance is A by root 2, which is beta in this formula. And gamma is the depth of this vertex, which is the length of diagonal AC, which is A into under root 2. So putting the values of alpha, beta and gamma here, we get the value of x1, which is given by 7A upon 6 under root 2. Now to find x2. x2 is the depth of center of pressure of this triangular area ACT. Now again here alpha, beta, gamma, alpha will be 0, beta will be this distance, which is equal to AP, and AP is half of the diagonal AC, so that will be A by root 2, and depth of this vertex is AC, which is A under root 2. So substituting the values in this formula, we get the value of x2, which is same as which we obtained for x1. It is 7A upon 6 under root 2. Now to find P1 and P2. P1 is the thrust on the triangular area ABC. That will be given by the pressure at the center of gravity of this triangular area into area of triangle ABC. Now pressure at center of gravity of this triangle, that will be given by rho into G into depth of center of gravity, that will be 0 plus A by root 2 plus A under root 2 upon 3. So this is the pressure at center of gravity into the area of this triangle. This is right angle triangle, so area will be half into base into height. Base and height both are having the length A, so area will be half A square. So this is the value of P1. Now to find P2. P2 is the thrust on the triangular area ACD. Again, by using the same formula, pressure at the center of gravity of this triangle into the area of triangle ACD. Area of triangle ACD is again half into A square, and pressure at center of gravity is rho into G into depth of center of gravity is 0 plus A by root 2 plus A root 2 divided by 3. So we have obtained all the 4 values P1, X1, P2 and X2. Now we can substitute these values in the formula for center of pressure of the compound body. Here the compound body is square, so the depth of center of pressure is given by P1 X1 plus P2 X2 upon P1 plus P2. Substituting all the 4 values here and simplifying, you will get the value of X, which is 7A upon 6 under root 2. This is the distance AP. Now, in our problem, we are to find the ratio of AP and PC. Now to find PC, from here you can see PC is AC minus AP. So AC is the length of the diagonal of square, which is side into under root 2. So that will be A under root 2. So A under root 2 minus the length AP, which we obtained already. Simplifying this term, we get the value of CP, which is 5A upon 6 under root 2. Now we can find the ratio of AP and PC, which is given by 7:5. So this proves that P divides the diagonal AC in the ratio 7:5 internally. So these were some examples based on the topic effect of further immersion. And this completes your one of the chapters in the second section.